All right, welcome back, and here we are for compound interest on this particular video. And compound is the more common form of interest that you'll find on a lot of savings accounts and other investments that you run into. And compound interest is particularly popular because what it does is it pays you interest on the balance in your account at the time of compounding. So, quick little difference here. Simple interest is paying interest on what I'd like to call a static amount. Okay, and by static, I mean that amount doesn't change. However, compound interest pays on a dynamic amount. And what I mean by that is that the amount of money that you earn in interest depends on how much money you have. So let's take a look at a situation where we have compound interest. Okay, so here we go on some compound interest scenarios, and this is actually kind of cool. It says you have a savings account that pays 4% per year, but the interest is compounded quarterly or 4 times per year. And that's not uncommon with most banks. If you start off with $100 on January 1st, then you need to know how much money you're going to have in a year. Now, if you are paying 4% per year interest, then what you must do is that you must divide that rate by the number of times that you're compounding per year. See, they're not going to pay you 4% for just 3 months. They're going to pay you just a portion of that. So every quarter, you are earning 1% interest on this particular scenario. So at the end of March, you've got $101 because you earned 1% interest. Now, for the end of June, the second quarter, you didn't just earn 101, you earned a whole extra penny there because $1.01 is 1% of 101. So now what you will have at the end of 2 quarters is 102 and 1 cent. And that's what you begin with to start the third quarter. And now you've got interest paid of $1.02 because that's 1% of $102. So now after 3 quarters, you have $103.03. And then what you will have at the end of the year is you're going to have another $1.03. Now, I know this doesn't seem like a pretty exciting example because it's pretty low money value, but it's easy to understand where we get the money from because you're getting paid on what's in your account, not what that static amount was at the beginning. So at the end of the full year, you'd have $104.06. Now, if you had done simple interest, you'd just have $104, but you get that extra 6 cents because you were compounding quarterly. Again, I know it doesn't sound like much, but if you were dealing with a much higher rate and a lot more money, imagine how much that could have an impact on what you're trying to accomplish. So let's look at the formula here real quick. And as we take a look at this formula, you will notice that it seems very complicated, but I'm just going to boil it down and keep it very simple. And I really want you to focus on what's right here. Okay? Now, there are 2 parts to this formula that are really important, but the most important things that you need to know for now is that A is the account balance, or the future value. And if you remember, that's what happens after we have our interest accumulated. And our P is our principal or our present value. And again, that's the amount of money that we start with in our situation. Now, there's a couple of things that we need to watch out for here that are really important. And that is this I, which is not just an interest rate, but what's called a periodic interest rate. So when we start talking about this idea of a periodic interest rate, what we need to do is look at this and say, okay, this is a periodic rate. This is that 1% that we had in the previous example. That's that 1% per quarter. So what you do is you take your rate which is usually quoted as an annual rate, and then you have to divide it by the number of times that you compound per year. After you do that number of times compounded per year, now you've got to factor that in with something else here, which is going to be our n. Okay, now what is our n? Well, that's our exponent, and that is the total number of times that you compound. So let's take a look and see the example off at the right here. If your rate was 8% compounded quarterly over 5 years, then your I would be 0.08 divided by 4, and the reason why 4 is we're compounding quarterly, so it'd be 0.02 if we wanted to work it out. And the n would be 4 times a year for 5 years. You would get paid interest a total of 20 times over that 5-year period. So that would be your I, and that would be your R for that scenario. Okay, let's put this into action and see how it looks on a real problem. Okay, we have that we've got $1,000 that's deposited into an account that pays 4.25 compounded annually. Okay, now annually is once per year. If we are compounding annually, then we don't have to worry about adjusting our interest rate or our exponent. So let's look and see how that's going to come out as a formula. Our account balance, our future value, is going to be $1,000 times 1 plus our rate, 0.0425. Now, normally I'd divide that by something, but since I'm compounding annually, I'm really dividing by 1 here. So I have to give you the heads up that the dividing by 1 is optional for this problem. It's really optional in this situation. Okay, now what about our exponent? Well, our exponent is just simply going to be 6 because this is once per year for 6 years. Okay, now, as we go to put this in the calculator, you want to be really careful how you type this in. Make sure you're following your order of operations carefully as you go to figure out how much this works out to be. And if you do it correctly in your calculator, you're going to get $1,283. And if we round, it's going to be 68 cents. So that's our total for that particular investment. Okay. All right, let's do this again here real quick. Find the amount of interest earned by a deposit of $24.50 for 6.5 years. Okay, that's kind of novel, so we'll have to look out for that. And 5.5% compounded quarterly. So there's really not a wasted word in this problem. We've got to be awful careful about this. So let's go ahead and set up our formula. Our account balance is $2,450, or that's the principal, actually. That's our P. And then my rate is going to be 0.0525, but I have to divide that by 4. And the reason why I have to divide that by 4 is because we are compounding quarterly. So that's something I've got to watch out for as I go along here. Now, about that exponent, I'm doing this for 6.5 years compounded quarterly. So if I'm doing this for 4 times a year for 6.5 years, that's going to be a total of 26 times that I get paid interest. So my exponent here has to be 26 in this situation. I'm going to take a second and plop that into my calculator. And again, just be very careful with your parentheses to make sure you get everything correct. And after a period of time of 6.5 years, you should have $3,438.78 in this account. All right, good stuff so far. One more quick example, and I think we should be good here. What is the balance in an investment of $3,500 that pays 2% compounded every 6 months after 5 years. Okay, so some key words and phrases here. If it gets compounded every 6 months, that indicates to me that we're getting compounded twice per year. Okay, so let's see if we can get the setup correct here one more time. Our P is 3,500 once again there, and our rate is 0.02, but since I'm compounding twice per year, that's going to be a big thing there. I have to take this and divide it by 2 in order to make it work. Now, let's see if you can figure out the number of times that we are compounding interest. Twice per year for 5 years. So that means my exponent is 10. Twice per year for 5 years is 10. So let's punch that in and see what we come up with. And if we get this correct, I'm going to end up with $3,866.18 when I round to the nearest penny. Okay, so that's your summary on compound interest.